The collection of air quality data is important for a number of uses, including checking if statutory air quality standards and targets are met and reporting on this, informing the public about air quality, identifying pollution hotspots, understanding long-term trends in pollutant concentrations, and assessing the effectiveness of air quality policies to control air pollution. In Europe, the Ambient Air Quality Directive sets out the requirements for air quality monitoring in EU member states. Countries are split up into air quality zones for the purposes of air quality reporting. The air quality monitoring requirements for each zone then includes the minimum number of sampling points, the location of monitoring stations, pollutants that must be measured, data quality requirements, and certain reference methods for measuring different types of pollutants. The directive also sets out requirements to inform the population about ambient air quality in their country or city. It's not just air quality data that is useful to collect. Mobility and transport data are valuable in being able to assess a city's current travel situation. Determination of the modal split between journeys, for example, those made by private vehicle, public transport, bicycle, or on foot, can also help the city to work out where improvements can be made in terms of air quality. There are a variety of methods for collection of mobility and traffic data. The most simplistic of these is a survey, which could be conducted online or by traffic counting officers in areas of interest in the city. Automatic traffic counting is another more reliable method of collecting information, but the initial costs will be greater than for a survey. A number of German cities have made use of surveys to assess their baseline modal split and then set targets for improvement based on this. Essen's target is to achieve 4 times 25, or a 25% split of journeys via public transport, private vehicle, by bicycle, and on foot. The largest challenge being decreasing the share of journeys by private vehicle from 54% down to 25%. In Mannheim, the system of representative transport survey, mobility in cities, has been used to gather information not only about the modal split between journeys, but how this modal split differs depending on the length of the journey. This has allowed the city to map out which journeys should be targeted for promotion of different mobility options. One of Hamburg's intelligent transport systems projects involves the installation of infrared or thermal imaging cameras on traffic lights around the city. They are used to record data including vehicle type, traffic volume, and even vehicle occupancy. Air quality forecasting uses a combination of pollutant concentration measurements, weather data, chemical transport models, and atmospheric dispersion modeling to predict pollutant concentrations or the air quality index for a specific location at a certain time. Pollution forecasts are often communicated to the public using maps with a color scale that indicates the level of pollution. This scale could reflect actual concentrations of one pollutant or represent the air quality index, which takes into account multiple pollutants. Air quality and mobility data can be used to help prioritize air quality measures and to monitor the impact of measures to address pollutant emissions from transport over a period of time. In addition, these measures are also able to improve the quality of life in a city by informing the administration as to what the current traffic-related issues are, such as congestion periods, so they can be addressed. Providing easy-to-interpret pollution forecasting maps also enables the general population to get interested in air quality and makes the information more accessible to the public. These types of measures, reducing emissions from transportation sources, will be able to increase the effectiveness of pretty much any type of air quality improvement measure, no matter the source of pollution, and also link well into communication and engagement measures.